Hello, everybody. How are you? Okay, so today I want to talk to you about the future. Just like Blade Runner in 1982 was talking to us about the future. Now, before we talk about it, we'll talk just a little bit about the present. Now, if you use Google and do a search, if you use Alexa, if you use Siri, or if you get into one of these self-driving cars, you are today using a form of AI. So AI is increasingly pervasive in our world today, for sure. Nothing new here. However, if you look at the advances in AI over the past many years, most of them have been based on this. And this is a neural network in a vernacular called deep learning. Now, deep learning is great. It's very good at developing higher order abstractions of things. It's good at unstructured data, so computer vision, for example, or computer hearing makes use of deep learners. However, deep learning is not the be-all and end-all of AI. Deep learning has limitations. One of the obvious limitations of neural networks are that they are data hogs. They consume a lot of data. They're also very narrow in scope. If, like Google, you develop a deep learner or two deep learning networks in this case, with a decision tree in the middle that tackles beating the world champion at Go, that still cannot play chess. So, very narrow and not versatile. Most importantly, if you want to push the envelope, if you want to really try to develop the next architecture of a deep learner, it takes you a lot of work. A lot of PhDs, data scientists, and technologists, years of work, and then you get something. And it's expensive, and it doesn't scale. So how do we take it from here? How do we begin to scale AI? So why am I showing you a picture of an X-ray? I'm showing you a picture of an X-ray because research in Italy recently has showed something quite remarkable, and that is the human body can adapt to completely new threats and new circumstances. The case in point here is that doctors that are using X-ray-based catheters to operate on hearts of people, these doctors' own bodies are changing based on their exposure to X-rays. They get a higher level of something called hydrogen peroxide, which means their cells are not doing well. Their cells are damaged. But also, they get a much higher level of antioxidants, which means their body is producing defenses that react in real time to a new threat. The evolutionary process for humans has never prepared us for dealing with X-rays, and yet the body is adapting. So if the body can adapt, how about AI, right? Now, I talked about deep learning being not the be-all and all of AI. So there are algorithms that will evolve. Evolutionary computation, recurrent neural networks, deep reinforcement learning are all algorithms that will self-learn. But when they do self-learn, they need horsepower to back them up. And at Sentient, we built one of the world's largest capability to develop self-learning algorithms. Not just the algorithms, but what you can see on the screen here, which means a lot of compute. And when I mean a lot of compute, I mean a lot of compute. Over the past 18 months or so, Sentient has been arguably the world's largest user of GPUs, at least in the civilian sector. And you can't find 6,000 GPUs in Amazon or Microsoft or Google Cloud. So you have to be smart as to how you get them. When you get them, then you begin to do things that are really interesting. I'm going to talk about some use cases. One thing that struck me when I was preparing this presentation was when we moved roughly 20 years ago to shopping in a physical store to beginning to shop online, we actually took this experience and boom, ported it online without much change. If you think about a brick and mortar store, the walls are fixed, The doors are fixed. The decor doesn't change much, right? The furniture doesn't change much. The sales associate is kind of the same day after day, week after week. And when we took this and moved it online, we did not take advantage of the flexibility and adaptability that the web gives us. We go to a store now, virtual store. It's still pretty much the same store from today to tomorrow. So can we begin to change this? Can we begin to think of the virtual world working for us as opposed to us working for it, conforming to it? And that's the idea here. And that got us to think about using deep, self-evolving AI to evolve that virtual world. That's how it looks like. What you see here is sort of this A/B testing process on steroids, and on steroids. The system here self-designs websites. Those websites are self-evolved based on how they interact with your audience. It can be content, so images, videos, text. It can be placement of this content on your page. It can be styles, font, colors. It can be the workflow. How do you move from page A to page B to page C? This is deployed now across dozens of companies, the latest one being Rakuten in Japan. And unlike the A/B testing industry or even the multivariate testing industry, we're looking at millions of combinations and evolving these in real time. Results are astounding. We have not seen any failure in deployment. Conversion ratios increased by a factor of 6% all the way to 600% in dozens of deployments. So that's an example of how you can use self-evolving AI. Now, in continuing with my metaphor with science fiction movies, if you recall, this is Minority Report, a movie which was released roughly 10 years ago. And in that movie, Tom Cruise enters a Gap store, and there's a video that comes up and asks him about his tank top, and asks him whether he wants something like that. Now, what's interesting here is that this video kind of tells an accurate story of what this is becoming, the retail experience is becoming. Today, we can already do merchandising based on an interaction between users where the system can detect what is it in a picture which you like and what is it in a picture that you do not click on which you do not like. And based on this, the system self-curates in real time products and options that are relevant to you. This system is in deployment in many retailers in the US, for example, Skechers, for example, Sunglass Hut, and Exotica. Now, what if you can take this further, just like in the movie, now moving from merchandising to advertising? So this example here is you've got a Facebook page, the users say, stopped its shopping journey the day before, didn't buy, didn't click on purchase, and now the next day is in his Facebook page and he gets an ad. It is not any ad. It is an intelligent ad that understands where the user was in his shopping journey and curates in real time, just like in a movie, options that are relevant to him or her in real time, understanding his intent. Now, you can push this further and begin to think about videos. So let's say you're shopping for a safe car, like a Volvo, of course. Shopping for a safe car. You're going to go into the Volvo website. You're going to see a couple of videos. That's the experience today. What if you could begin to see something a little different, where the system curates in real time a hyper-personalized video for you, which takes into account your emotional state, which takes into account the story you want to be told, and the way you want it to be presented, colors, font style, the storyline, and so on and so forth. This is coming. The reason why I'm not showing it to you yet is because it is in the works. But by this time next year, I expected it to be able to show it to you. That means we're taking the experience from just website and merchandising now all the way to advertising. One more use of video is this. This is also in production. So the idea is, can you use a deep learner and a series of deep learner and a self-evolving system to be able to observe the world and progressively build an ability to recognize goods, objects in real time in video streams like this one, and then gives you the ability to discover that online. The system does it, and it's used, of course, the enormous amounts of capacity, compute capacity, which we have to make it work. So that's the future of retail. And the future of retail is great, but I want to be able to talk about something now a little more scalable. What about healthcare? What about consumer services? What about finance, insurance? What about agriculture? How do we scale AI so that we build that hyper-productive, hyper-efficient world that serves us humans? Now, to do that, I need to go back to Blade Runner. Now, you will recognize that we've had a lot of fun spoofing Blade Runner, both 82 and 49. We do not call these guys evolvers. We call them ENNs, for Evolved Neural Network. The process is called neuroevolution. This is not science fiction. It is real. And what it does is that it enables designed AI to self-design. This is how it looks like. If you look on the left side, you will see a semantic representation of a neural network. Each box here represents a layer in a neural network. The system here, self-built. It observes the world, and based on feedback and interaction, it progresses to the next generation, and the next generation, and the next generation, and improves along the way. This is how you can begin to truly scale AI. Now, this is not only evolving in a vernacular hyperparameters of a neural network. It is evolving that plus the components and the topology. In other words, the whole architecture of a network is evolved. Now, how do we use this? How do we use this self-creating intelligence? Here's an example. There is a service that Google has developed over years called Google Show and Tell, and that is about image captioning. Years of work. So we took this self-learning system and tried to see whether we could match or even exceed the performance of Google Show and Tell. We used 3 days, 100 GPUs, and a system that I just showed you. And this is what you get. What you get is already stuff that is exceeding the benchmark. That is pretty good, right? A man in a suit and tie standing in a forest. Now, this is a good thing. Now, I'll show you in a second the not so good. So, science fiction still, the metaphor. So, C-3PO and R2-D2 are a black and white motorcycle, a mess. And the alien drawing is a pair of black and white striped socks. So, not quite there. Intelligent systems, like we humans, will make mistakes for sure, but the important thing is that over 3 days and 100 GPUs, we're able to match years of work that Google did. Now we're going to move this system now to 10,000 GPUs and a few weeks of work, and imagine what that's going to do. So, in closing, if we can do this, then imagine what we can do trying to solve other problems. Now, I'm not saying that we should try to become Blade Runner 49. This is not the idea. But there are things that we can do that already are telling us that we can get to that future, the good parts of that future, not the bad parts of that future, where we can be creating extreme wealth, extreme health, and success for our species. With this, I would like to thank you very much for your attention. Wish you a great end of the summit and a great future. Thank you all.